Okay, I'm just going to have a short video here, the last of them on Chapter 9, which is port address translation. And you're going to see once again just how similar this is between dynamic, static, and those. So configuring PAT, port address translation. Let me just show you port address translations. And I'm going to move fairly quickly because it's so similar. So very much like dynamic, it just comes right on the heels of dynamic address translation. You create a pool. And here I've created, the same as in your text, is created the very same pool, 209, 200, 226, right, to 240. Those right there. And then here's the netman. Now notice this 224, that's a very tight mask, so it's really showing a pretty small number of available addresses, and indeed it is 226 to 240. So we saw those before. We just created netpool 2 is all, exactly like dynamic addressing, exactly. Okay, now you might expect, and you'd be right, the next step is we're going to create an access control list to permit those addresses that are going to be translated. Let's name them, right? So we got to go back to our access control list. This is not a new command. It's just the command for access lists, ACLs. Here's the list number. It's usually 1, 2, 10, something like that. It's a permit command, and what's the source, right? And the source will be a wildcard. So here's that specific one for us again. Same access list. We're in the config mode, just like up here, making pools and making ACLs, right? ACLs. We're in the config mode because we're building those at an upper level. They're not attached to any port so far. The number is 1, that's the name of it. It's a permit list, and it's everything prefaced in 192.168. Those are the match numbers there. Everything else can be what. So this allows an awful lot. This is like if you were to go back up here and give a prefix length instead of the max, what would it be? 8, 16, so it'd be only 16, right? Pretty small. So now those two things we've done before with dynamic, so we're comfortable with those. And then as you'd expect, we have to bind the two together. We need to link this access list to that pool. And it's our favorite command, the IPNAT command. Inside source, the source is going to be the list. The pool is going to be the name of the pool, right? Here's the thing that makes it port address. This is a new word that's attached, and so far this is the only difference you're seeing between dynamic NAT and port address translations, is the word overload gets attached to the binding at the back, okay, right before you're in the config mode. All of this will take place in the config mode. So what does this say? If I want to do port address translation, this is how I set it up in the privileged exec config mode. Then if I want to use it, if I want it to be effective, I need to go out to the two interfaces like we've been doing and use the inside NAT address, inside NAT command over here, and the outside NAT command over here. Okay? So you can see, except for this word overload, you're basically doing dynamic NAT. Okay? Is there anything like static or a single address? And let me just whip through that real quick because you're going to see how different can this be from port address translations. You define the ACL. Okay. Now, what do you mean decide? What's single? This means no, bad writing here, no pool. Right? No pool. Single address. So you define the ACL then. You can skip that whole first step of making a pool. Define the ACL. Same one. All right, we define the ACL, and then we establish the translation, right? So what did we do? We basically just lost the pool step from the previous slide, from port address translation. IP NAT inside source, we're going to take things in this list, and now we don't have a pool to specify. We have an interface. Right, so anything going, now notice this is the outside interface. It's this one over here. It's highlighted in orange. It's that one. Right? Anything on the inside in this access list, and these are inside addresses again. Let's be clear. Inside stuff, inside, going to that interface, and there's our command that says port address translation. That's the thing that calls it PAT, right? That's the little adder that makes it PAT. So again, you're seeing single address PAT is the same as PAT, except you get rid of the pool. And when you got no pool, the translation command says, okay, you got to name where am I going to do this? You got to name it. Right, so, and then you finish up, of course, by going to these two interfaces and invoking the NAT. Okay? Now, in your text, and you can walk through these two, but this is basically the description of port address translation that I did in lecture 2. So I don't think I want to go through that. I want to just finish up here with something called port forwarding. And, once you're down messing in the ports, it's kind of like, what else can you do when you're there? So this is thinking larger, because a problem arrives when you do port address translation and maybe even some of the NAT translations. So port forwarding, that's forwarding a network port from one network node to another. Okay, now that doesn't seem to have anything to do with address translation. And it doesn't. It's just sort of saying, what is port forwarding? But you have to think about, there could be a lot of other stuff going on outside, in the outside network, where people want to get to an inside network. In all the pictures you've seen so far, the inside network has been sort of pictured as the home network or the office network or the DKI tech building. That seems to be the inside network, and it wants to get to the outside world. That isn't always the case. Sometimes, depends on how the network address translation is set up, right? You could be sitting at home, and you could be suffering from network address translation out on the servers that you want to get to for information. And that's a problem that comes with port forwarding. Let me say a little more and you'll see it. A packet that is sent to a public IP address and port can be forwarded to a private one with port forwarding. Okay? So remember, the private addresses are inside, the public ones are outside. If you're sitting as a client outside and you want to get to a server someplace that's private, okay, you're an outsider coming to, you're coming from a public place trying to go to a private place. And NAT isn't going to let you do that, because the problem is hidden internal addresses as a result of NAT. Here's the problem. Remember, NAT is a private to public translation. So if you're sitting at your computer and you don't know it, you're in a public place, and I don't mean the library or someplace. I just mean in terms of address space, you're in public, and you want to get to something that's private, maybe owned by somebody, other than has your best interests or whatever. They're trying to protect their stuff. You need to have a way to get into that private address if you're going to be allowed. So that peer-to-peer, I'm telling you this, peer-to-peer only works from inside to outside networks. And quite often when you're sitting outside, you're in network space, you're public. And you want to set up a peer-to-peer relationship with a server someplace that's private. You're not going to be able to do it unless port forwarding is present. So port forward is helpful in these situations when servers are private and not reachable easily from the outside. You have this picture, this kind of pictures it. Here's something called the POS server, and you're out here in public space. The internet, that's you, and you're trying to get to somebody's private space. This is a small office, home office router, right? So the router needs to be set up to say, I got to forward packets to the point of service server or POS server, whatever that is. That could be point of sale. See, so naturally that's going to be private. That could be inside Macy's, right? Or inside a small business. That point of sale server, things that match a specific destination port. So I'm going to allow a setup of peer-to-peer, provided everything is allowed and specific. I'm not going to allow people to be roaming around here in a pool of addresses, okay? So that's what port forwarding is. And there's just this one command, right? IPNet inside source, we're familiar with that. And it'll be static, but now you're going to have to specify, is it a TCP connection? Is it a UDP connection? Right? A TCP or UDP. But now you're going to have the local IP and the local port, and the global IP and the global port, right? So you can already anticipate, man, I've seen this command connecting things before in port translation. So this just now gets more specific, where I'm actually going to connect ports as well. All right, all these details are just specified. This is an option, the extendable, but remember, extendable is that word, or overload is that word that we had before. Here, but that was not optional. This one is. An extendable means I can do more than one. I can do more than one peer-to-peer setup. Okay? And this just says, is this port number and this port number, are these TCP or are they UDP ports? Which are they? Okay? So that's what's going on there. And, here's how that looks. No, I just took these straight off the text. Everything looks the same. Look, we're familiar with seeing this interface, serial 00, make it inside, serial 01, make it outside. Here's our command. I'm going to hook TCPs to 192.168.10.254.80. So I'm telling you this specific address, port 80. So when it gets over here, port 80, right, I'm going to connect that to 225.880, right? So I'm going to allow it to go out right there, that source with 880 attached to it, right? I'm going to connect those two guys, all right? So that's just port forwarding. It's the same process, almost the identical same commands. In fact, it is. Here the extendable is not on here. No extendable in here. it says I'm going to allow that specific one to be attached to that specific interface, but more than that, it must have that address on it, and that port number on it, and it must have that port on it. A very tight, specific one. And I could repeat this, right? If I had extendable attached here, I could add another one of these and another one of these and another one. See, and if I didn't use the word extendable, I'd be overwriting what I'd already said. Let's say I repeated this step again and again and again, but with different addresses. Each one would overwrite the other one. But extendable says, no, keep the list going. Okay? So that's port forwarding. We'll not be doing much of it except what I'm showing you right here. It's kind of built in. If you ever go prowl around your home router, you'll see this looks like a Linksys command page if you get into it. Mine on Netgear have all the same information, but they look a little similar. But here you can see, you know, what exactly gets connected. But this port style is very, very similar to the built-in stuff at home. Okay, it's the default stuff at home. Okay, one quick thing on NAT you might ask about it versus IPv6. Do we even use it for IPv6? Because I mean, what? NAT for IPv6, we got zillions of addresses, so address space is not an issue. We don't need address translation in order to extend or enable more addresses or conserve addresses. That's really what NAT is doing. So IPv6 really makes IPv4 public to private NAT unnecessary. That's the design, part of the design of IPv6. And it doesn't have the form of private addresses implemented the same as IPv4. It's a little different, right? So how do we do it? Let me just make these few comments. It uses NAT, but has a much different context. NAT provides transparent communication between IPv6 and IPv4 networks, and that's really the the main thing why we did it. We had people were starting to develop IPv6 networks, and they had plenty of address space, and they were really at risk of losing touch with IPv4 networks, right? So here you have a router that is shown standing in the middle of several types of networks: IPv6 only, IPv6 internet networks, IPv4 internet networks. How do they keep in touch? Well, there were several protocols developed, and I guess the important thing is this one shown here, NAT64, NAT64, that's cute, is not intended to be a permanent solution, and actually an awful lot of solutions have been proposed. There have been a lot of other attempts, as you can imagine, because people were designing equipment, and it's, the IPv6 and IPv4, NAT clearly is an IPv4 issue. And IPv6 came along, and so it's like, what do we need with that? But when you cross boundaries, and you may have solely IPv4 networks, you got to have some way to make sure that IPv6 doesn't end up unable to access those, or IPv4s are not able to access IPv6s, okay? So right now, NAT64 is the recommended one out of the whole bunch, but even that one is not permanent. Okay, so this is it for NAT and Chapter 9. Remember, it's not a difficult concept, and as I hope I've shown, there's very few commands, and they're all the same. You just change a few keywords, and that's what there is. That's all there is to it. Okay? So I'll move on to Chapter 10 from here. Thanks.